Intervals are a way of measuring the difference in pitch between two notes, basically how far apart the two notes are. In Western music, we use 7 basic note names: C, D, E, F, G, A, and B. Then, as we go higher or lower, the same note names repeat. The distance between a note and a higher or lower note of the same name is called an octave. In Western music, we've subdivided this distance into 12 equal steps. These steps are called semitones. Now, an easy way to measure the distance between two notes is to count the number of semitones between them. And that's absolutely valid, but intervals are slightly more complicated because they also give us the musical context of that distance. So let's dive in slightly deeper. Intervals have 2 characteristics: value and quality. Value is pretty straightforward. Let's number all the notes in an octave starting from C from 1 to 8. We call this series of notes a scale, by the way, in this case the C major scale, but that's a subject for another video. So now let's start measuring the distances between this C and another note. C to D is called a second. C to E is called a third. C to F is called a fourth. C to G is called a fifth. C to A is called a sixth. C to B is called a seventh. And as previously mentioned, C to C is called an octave. And finally, a more special case: if the second note is the exact same C, the distance between them is 0, and we call this interval a unison. So you can see that there's a direct correspondence between the position of a note on the scale and the value of the interval. But that's only half the story, because now we need to define the quality of these intervals, and this is where things become slightly trickier. The quality of an interval can be perfect, major, minor, augmented, and diminished. Unisons, fourths, fifths, and octaves can be perfect, augmented, or diminished. Seconds, thirds, sixths, and sevenths can be major, minor, augmented, or diminished. The reasons for this quirk are partly based on history and partly based on physics, but let's accept it for what it is and quickly go back to our original example and see what these names mean, because it's not as complicated as it sounds. The intervals in our C scale happen to be very easy to fully name. C to the same C is a perfect unison. C to D is a major second. C to E is a major third. C to F is a perfect fourth. C to G is a perfect fifth. C to A is a major sixth. C to B is a major seventh. And C to C is a perfect octave. Now, if an interval is a semitone larger than a perfect, then it's called augmented. And if it's a semitone smaller than a perfect, then it's called diminished. For major intervals, if an interval is a semitone larger, then it's called augmented again. If it's a semitone smaller, then it's called minor. And if it's a semitone smaller than a minor, then it's called diminished. So now we can deal with all those notes in between. And that's when things start becoming interesting. This note over here, depending on the musical context, can be called both F sharp and G flat. The distance between C and F sharp or G flat is 6 semitones, but the name of the interval between C and F sharp is actually different from the interval between C and G flat. Let me explain. As we saw earlier, C to F is 5 semitones, or in other words, a perfect fourth. F sharp is 1 semitone further, and we said that the quality of an interval a semitone above a perfect interval is called an augmented. So the value of C to F sharp is still a fourth, because F sharp is just an F that's been raised by a semitone, but it's an augmented fourth. In the same way, C to G is a perfect fifth, but C to G flat is a semitone closer. We know that the value between C and G is a fifth, and that the quality of a perfect interval that's been lowered by a semitone is a diminished, so that makes this interval a diminished fifth. So just to drive it home, let's apply the same logic to this note. The distance between C and this note is 10 semitones. If we call this note an A sharp, then the interval between C and A sharp is a sixth in terms of value, since the position of A relative to C is 6, and it's augmented in terms of quality, since the distance is 1 semitone larger than a major sixth. So we can call C to A sharp an augmented sixth. Now, if we call the same note a B flat, then the interval becomes a seventh in terms of value, since now we're dealing with a B, and it's a minor in terms of quality, since it's one semitone smaller than a major seventh. So C to B flat is a minor seventh. Okay, deep breath. It's not that complicated, but it takes some practice to get used to the logic. Give it a go, try naming these intervals, and leave a comment with your answers. If you can't be bothered but you've made it this far, then leave us a like to tell our algorithmic overlords that this video is worth your time. Now I'm gonna try and preemptively answer 3 questions that you might have. What happens if an interval is larger than an octave? These intervals are called compound intervals, and they're pretty simple to define. To calculate a compound interval's value, we can continue numbering the notes above the octave. So for example, this E is the 10th note in our C scale, so this interval is a 10th. And to find its quality, we look at the quality of the interval between that second note and the octave of the first. In this example, it's a major third, so the compound interval is a major 10th. Similarly, this is a major 9th, and this is a perfect 11th. What if the distance is smaller than a semitone? These intervals are not very common in Western music, but they definitely exist, and they're called microtones. Microtonal music is a whole different rabbit hole, and we can explore it in a future video if you'd like us to. The main thing you might want to know is that semitones can be actually subdivided into a further 100 tiny equal steps called cents. If you've ever tried tuning a guitar or tried pitch correcting audio in a DAW, you're probably familiar with the term. So if an octave is split up into 12 semitones and each semitone is 100 cents, an octave is actually divided into 1,200 cents. And finally, what's the point of all these different interval names? As we said before, there's nothing wrong with just saying that 2 notes are X semitones apart. The whole point about intervals is to state that distance in the context of a musical piece, rather than just the physical distance in pitch between the 2 notes. This can help you better understand more advanced concepts, such as how scales and chords are built. So if you want to learn more about the basics of music theory, go watch our other videos, and we'll see you over there. Bye bye!